Hi everyone. In this video, you will learn what Calculus 1 is all about. If you would like to follow along, you can download these notes using the link in the video description. Let's start with an exercise. I want you to copy the words in the first column, exactly the way you see them. And then I want you to fill in the blanks to create words in the second column. If you are going to complete only one exercise today, please make sure it's this one. I promise you, you will not regret it. I will come back to this exercise at the end of the video. Now, let me tell you what Calculus 1 is all about. There are two major themes in Calculus 1: instantaneous rate of change and area. Calculus 1 asks two major questions: how fast things are and how big they are. How fast and how big. Let me give you a couple of examples of each. Imagine you just drove 60 miles in 2 hours. What was your average velocity? I believe many of you would say it's 30 miles per hour. You simply divide 60 by 2. This is a general formula for average velocity. You take the change in position and you divide it by change in time. And I'm using here a symbol delta, which stands for a change. How would you compute instantaneous velocity? The word instantaneous means at an instant or at a particular moment. For example, what was your velocity at 1 hour, 2 minutes and 3 seconds? You can no longer use the formula for average velocity because during an instant, there is no change in time. So, how do we compute instantaneous velocity? Which, by the way, is an example of an instantaneous rate of change. This is a question that Calculus will answer. Let me give you another example, this one involving a function. The function below is x squared. How fast does this function change? You can describe it in words. You can say that at the beginning, the function was decreasing fast. Then it was decreasing, but not as fast anymore. Then it stopped decreasing and started increasing. And then it kept increasing faster and faster. This description is accurate, but it is not precise. Mathematicians need a numerical value that will describe exactly how fast this function was changing at this point. They need a numerical value that will describe the rate at which this function was changing at this point. For example, choose x equal to 1. X equal to 1 corresponds to the red point I just added to the graph of my function. Now, you might want to know how fast does f change at x equal to 1? Calculus 1 will answer this question. Let me give you an example involving area. Consider a circle. A circle has a center. A circle also has a radius, which is the distance from the center to the edge of the circle. The radius is often denoted by the letter r. You may know that the area of a circle is given by pi r squared. The question you might have is why? Why is the area of a circle given by pi r squared? This is a question that Calculus will also answer. Let me give you a final example. Again, consider the function x squared. Now, what is the area of the region between the function and the x-axis and between x equal to 0 and x equal to 2? What is the area of the green region? That green region is not a familiar geometrical figure. It is not a square, it is not a rectangle, it is not a triangle, it is not a circle. What is the area of this region? That is a question that Calculus will also answer. There is one final question, probably the most important one, that calculus asks and answers. The question is, why would you care? Why would you care how to compute instantaneous velocity? Why would you care how fast a function changes at a given point? Why would you care that the area of a circle is pi r squared? And why would you care what the area of a region under the function is? Calculus will answer that question too. At the beginning of the video, I told you that I was going to come back to the warm-up exercise at the end of the video. Now, without looking at the first page, I want you to write down as many words from the first exercise as you can. Give yourself a minute or two to write down as many words as you remember, either from the first column or from the second column. When you're done, write down how many words you remembered from the first column and how many words you remembered from the second column. If you are like most people, then you remembered fewer words from the first column and you remembered more words from the second column. What's the conclusion? The conclusion is that active learning works. In the first column, the words were already written. You simply passively rewrote them. In the second column, you had to create the words. This means that actively engaging in tasks helps you remember the material better. In future videos, I will ask you many times to stop the video and try the problem yourself first. This suggests that you should do so. If you stop the video and try the problem yourself before you see the solution on the screen, you will remember the problem more and you will retain more in the future.